So since now we are done with the brute force method, let's try to do it with the optimal method. So yeah, we are here also. We'll do it optimally so that we can reduce the time complexity and space complexity for the given question. So how we'll solve this given question again is we have to take which array should I take? Okay, let's take the first array. First of all, let's delete all these elements. Okay, 0, 1, 2, 3, 4. Okay, 4 we have to take. Okay, for C, that will be again. Yeah, now our array contains what? 1, 2, 3, 4, and 5 for the first one. And the second one here is t is equals to 2. So 1, 0, and 2, we have to put it in the back. We have to get 3, 4, 5 in the front. So let's get it first. Let's put over here 3, 4, 5, 1, and 2. How can we solve it more optimally? One solution which comes to my mind is what I can do is first of all I'll separate till the D part. Taking D as index, I'll separate both these array from these all the given arrays. Then what I'll do is after separating these two parts of the array, I'll reverse both of them. Yeah. So the new array which I'll take is, so let's copy this, store here, take this part of the array and separate it. After separating both of them, what I'll do is I'll reverse both of these parts. Yeah? So here in this case, I'll have the 2 over here, the 1 over here, and for also this 3, 4, 5, I'll take these two elements, like these three elements, sorry, copy this, paste it over here, reverse it. Now it will be reversed. 5 over here, 5, 4, 3 will be the reverse of 3 to 5. So now you can see what we have done here is we have partitioned it from the D index, okay, and we have reversed the two newly formed arrays. And now what I'll do is I'll reverse this whole array, this array as a whole, to get my answer. So if you see properly, here we have 3, then for the same given array, and we don't use any external array or any external functions. So let's try to write the code for it. What we have to do is we have to make a function, a reverse function, pseudo code. What the reverse function will contain the integer array, then the start of it. This is basically the boilerplate for a reverse function which can be used in C++ Java. Anyway, if you don't have like reverse inbuilt function in your uh, library, like Python has it, but others don't. So while start is less than end, what I'll do is I'll take temp, a new temporary variable which I'll create, and I'll store ARR of start in that. Then I'll put ARR of end in ARR of start. steel. Yeah, and, yeah. And at last, what I'm doing is just basically swapping these two. Start and and start them, and then start while this. I'm doing what? Start plus and minus. So what will happen using this reverse function basically is, if you say it properly, while start is less than n, we will take the initial temporary variable 10, store the value of start over here. Suppose this one will be stored in the 10. Then start will have the value of the end array. So 5 will be stored over here. Okay. Then end is equals to 10. So 1 will be stored over here. The start plus plus means 1, like the start will jump from 1, 0 to 1, and n minus 1 is, which means 4 to 3. And this will happen till start is less than n. As soon as start becomes equal or greater than n, this will stop. And how many times we do this is, like we have to use this reverse ARR from 0 to d minus 1. Once we have to do this, then we will reverse ARR from d minus 1 till d we have to, so d to n minus 1. And at last, since we have to reverse the whole array, so reversal of ARR d ends to n minus 1. Using these three reverse functions, we can rotate this optimally. Also, the time complexity will be is equals to the same big O of n or d, big O of n. But in this case, the space complexity reduces since we don't use any extra array or something. Extra space complexity will be equal to O of n, O of 1. Yes. So yeah, that's basically